Alrighty. Okay. Minimum operations to make a uni-value grid. You're given a 2D integer grid of size m and n, m by n, and integer x. In one operation, you can add x or subtract x from any element in the grid. Okay, so strictly add or subtract. A uni-value grid is a grid where all elements of it are equal. Return the minimum number of operations to make the grid uni-value. If it's not possible, return a 1. Okay, so 2, 4, 6, 8. I guess you could possibly make it all 4s, increase this thing with 1 operation, decrease this with 1 operation, and decrease this with 2 operations, so that's 4. Okay. Or you can make it 6 as well with 4 operations. X is 1, 1, 2, 3, 5. You probably want to make everything 3s in 4 operations. No. 1, 2, 3, 4, 5. Yeah, 5 operations. Okay. Pretty straightforward in terms of what it's asking for. I think the first thing might be to do a sanity check to make sure that's possible. So sanity check for if possible, and it's possible only if each number is some offset of a multiple of the x. So for instance, if there was an odd number here, it wouldn't be possible because you can't get you can't do +2 to an odd number to get an even number. So basically if you subtract maybe the min value in the whole thing from the min value of the whole array, 2D array, from all the elements, everything that's left over should be a multiple of the x. If not, then it's not possible. So how to you could use any value really. It doesn't have to be the minimum. The minimum just makes it appear nice. But if this was 4, you subtracted 4 from everything, it would still be -2, 0, 2, 4, and thus all multiples of 2. And if it's multiple, if x is 1, then it's obviously possible. If x not equal to 1, we'll do everything, all values must be multiple of x, removing any offset. And this could be any element in the grid. So we'll just take the first value in the grid, so offset equals grid at 0, 0. Because this is a 2D array, I generally will always declare rows and columns. Rows and columns is equal to grid length of grid, that's the number of rows, and length of grid at 0 for the number of columns. I prefer that over m and n, which can be easily misread or confused. So for every element, every value for every row in grid, and for every value, for every index, every column index in the range of the number of columns, the row at this column index is going to be minus equal the offset and then if the new value is not divisible by x, then return -1. Alright, at this point, after it's done its sanity check, we know that everything's possible. There's some way of getting it all the same value. I wonder, feel like the middle, the mean, is probably just the best thing that you can get, right? Because even if it's a extreme, is the mean the best thing that you can get? Well, yeah, I feel like the greedy approach of just trying the mean. Try a greedy algorithm. Find number of operations to get to mean. And I guess we can, since we already went through all the rows and column values here, we can just calculate the mean simply as the total is 0 here, and then total plus equals this value, and then that gives you I'll also have a count, just a count of the number of elements, so that should be the number of rows times the number of columns. So the mean should be the division, and this is guaranteed to be a multiple of x. Let total divide by the count of elements. And then I'll just go through a second pass to determine how many values. Do I even need to go over a second pass? Is it possible? So is the mean guaranteed to be a multiple of the offset? I guess I think so. No, that's not true. Yeah, that's not true. The mean could be some decimal value. Okay, if the mean is some decimal value, then probably want to be something as close to the mean as possible. So I want to use round. So it's not necessarily an integer division. I'll just use math.round. I think math.round is the rounding method. Okay. And then get although if the mean is not actually rounded to an offset value, then I need to go to the closest offset value, or closest multiple of x value. Um, so if the mean was like 1 and the x is 2, like for instance it was a 0 and a 2, then it doesn't really matter. How do you get the mean closest to how do you round it to the closest x? So you have the mean. I think we divide it by x. That gives you a fraction. So total divided by count divided by x. That gives you a fraction of how many x's there are. You round it and then you multiply by x again. Okay, I think that's correct. I'll just do a quick sanity check here. I guess I can return 0. Total divided by count. Is it just round? Okay. Here the mean was not raised. Let me go ahead and just print out some more stuff to make sure. Print the new grid after making the offset change, the total count x. Alright, the new grid after making the offset change. That's really not correct. So the offset was, I guess here, okay. I actually don't calculate offset if x is 1. I guess I'm doing multiple things here. I also calculate the total, so I just need to always do this. I was thinking of having the not equal to 1 because it's possible to do x equals 1 at all times, but it doesn't really. I need to do that calculation at all times. Okay, so this one correctly identified that as not possible. Okay, so the mean here, so removing the offset, it's total 7, and the mean of 4 values, the total 7 would be 1.75. If you round that, that becomes 2, and you are trying to get everything to 2. Yeah, 2 because you offset by 1, so that's 3. Yeah. Here the mean was, total was 12 after you take away the offset. 5 by 4 is 3. 3. 12 divided by 4 is 3. 3 is 1.5 divided by x. So 1.5 rounded is 2. And then 2 times 2 is 4. So we're getting everything to 4. Here you could have got, if you rounded to 1, then you would have gotten 2 times 2 is 1, or 2 times 2. 2 times 1 is 2. And then, yeah, that's the problem. Okay. So, So how to let me clarify what's going on here. This is not really the mean. This is the greedy algorithm. Find the number of operators to get to the closest multiple of x. Closest multiple x to the mean. Okay, and then we just need to calculate how many answers, how many operations are necessary. So for every row in the grid and for every value in that row, answer plus equals the value minus the mean divided by x. I think maybe I need to take absolute value here. Math.absolute value. Is it just absolute? Huh, interesting. I thought it was math.absolute value. Whatever. Get rid of print and see how it is. Okay, wrong answer. So answer should have been 26, but my result was 25. So what to do here? How to use the test case here? All right. So let's go ahead and show the information. So removing the offset, those are the values. And then the total was 1012 divided by 9. 1012 divided by 9 is like 110. That's 90, and then another 990. Oh, well, what's 9? 9 is the count. Counts the number. Okay, 1012. 92 is x. So the mean of 112 or 1012 divided by 9 is like 900. Is that right? 9 times 900. 9 times 100. 112. Something like that. 113. 113 divided by 92 should be 1. So if I print out the mean, should have gotten 1. The closest so it should have rounded to 0, I think. Really? What to 90? 1012 divided by 9 divided by 92. 1012 divided by 9 divided by 92. Yeah, that is 1. So I'm getting everything closest to 92. So that's 1, 2, 1, 2. This is 5 times 92, so that's 4. 1, 2, 6, 10, 11, 12, 13, 14, 4, 18, 19, 20. That should be 6. 6. Huh. Oh, yeah, I see it. I think I see. Oh, so if you had a bunch, if your median, it's really weird. Your mean is above 1, but it's quicker to get everything to 0 instead of 1. How does that statistically work out? I guess it's either going to be, could be possibly, how much of a deviation could it possibly be? Could one outlier change the mean so much that your median values Alright, I guess, okay, I'm going to do two means. Mean 1 is going to be for the floor. I guess this has to be mathed up for. And mean 2 is going to be for the ceiling of the population. I think it's called seal. Python math.seal. And for the ceiling, yes, we're going to be total divided by count divided by x times x. And then we'll do two calculations. Answer 1 is this, answer 2 is this. Answer 2 plus equals, what's the value? Value minus 2 divided by x. I'll try the smaller of those two. Is this just 4? Okay. What is the actual calculation here? I think I can remove the offset rate. The offset doesn't matter. If you subtract something from every value in your thing, it subtracts the mean by that value. But that matters. Okay, so let me just print out what the means are at this stage. Is the mean here, this can be 92 and 184. Yeah, it's actually, what is the optimal thing here? Is the optimal thing 0? Alright, let's try mean minus. Let's try just hard coding this for -1. Let's see if I just use 0 and 1 as the multipliers rather than 2. What the heck? Is my calculation just wrong? Oh, 86. 86 is a multiple of, well, it doesn't matter, huh? The output was 1, expected is 0. I wonder if just any one number is not correct with this code here. Well, any one number, you shouldn't need anything. So let's say if the count is just 1, then return 0. Alright, still wrong. So, doing this stuff again. Alright, you have 0, -803, -292, and -219. -1314 is your total. Okay, 4 is your count, 73 is your x. So calculated number is either going to be -438 or -365. So if you go 73 to -803, this is hard to calculate in my head. Alright, what I think I should probably do is I should probably set the value to be subtract the offset and then also make it into a multiple of x to make this easier for me to actually I guess I need to subtract, check if it's a multiple of x. If it is, then set it to be the multiple of x. Equals, or divide equals x. Alright, at that point I really don't need to worry about what x is, since it's just going to track that. So here, I'll just go for of how far away it is from. So I don't need to divide by x and multiply by x anymore. here. So the array is just like, assuming x is like 1. Yeah, so this is just going to be value minus the mean. Okay. Alright, so it's 0, negative 11, negative 4, and negative 3. So what's the best thing here? The best thing here is not negative 6 or negative 5, apparently. It's, what is it, negative 4? Yeah, negative 4. So that'd be 4 plus 7 plus 0 plus 1. 4 plus 7 is, or 4 plus 7 is 11, plus 0 is 0, or plus 0 is still 11, plus 1 is 12. Interesting. Okay, I guess my intuition about how to find the best value to find the lowest absolute difference is not correct. Taking the mean is just not correct. Taking the mean is just not correct. There should be a way. There should be a way. The deviation, if for any given spot that you pick, is the deviation. So if you pick negative 6 or negative 5 or negative 4, for any of those spots, so let's just make these positive. So 0, 11, 4, and 3. So if I pick 6, this is going to be 6 difference, 5 difference, 2 difference, and 3 difference. If I pick 5, this should be 5 difference, 6 difference, 1 difference, and 2 difference. 4, this is 4, 7, 0, and 1. So any value that I pick that is between the min and max of my of the multiples of x, it's going to not affect the values that are at the edges, but it will affect the values that are in the middle. So it will affect the values that are in the middle. I mean, I guess I can do a binary search. Can I do a binary search somehow for the optimal? Anything that is let's see. So this is 6 plus 5 plus 2 plus 3 is 16. That's 14. 11 plus 3 is 14. 11 plus 1 is 12. If I pick 3, this is going to be 3, 8. 3, 8, 1, 0, so that's also 12. Pick 2, 2, 9, 2, 1, so that's 14. If I pick 0, 1, that's 1, 10, 3, 2, 16. So it gets smaller. It doesn't go to 0. It does get smaller. Can I make it so that's always decreasing? I guess if I didn't take the absolute value of the differences, this would be 6 would be positive 16. Positive 6, negative 5. Okay, let me do this one more time. But not ignoring negatives and positives. So if it's 6 minus 0 is 6, this is negative 5. 4 and 3 would be 6 minus 4 is 2. 6 minus 3 is 0, or 3, positive 3. And then 6 plus 5 plus negative 5 is 6. This would be negative. These would be positive, and we get down to 3. No. Negative 6. Positive 6, 2. This is going to be negative 7, 0, 1. This would be negative 2. And then this is going to be probably negative 6. 3, negative 8, negative 1. Yeah, negative 6. Interesting. Can I somehow conclude anything from it? What can I conclude here? This is kind of a binary search. You're searching for 0. If you're looking through, if you look through this calculation, if you're looking through this calculation for the thing that's closest to 0, I feel like you shouldn't have to do a binary search. You should be able to do this linearly, no? Clearly I'm wrong about that. Or clearly my linear approach is not working. Okay, I'm going to do a binary search. So I'm searching for 0 amongst these values. There's not is possible. I guess this is like just is negative, is positive. I guess define is positive. And this is going to be for some test case mean value. And then what we'll do is we'll take the total. We'll just go through for what we're going to do. We need to calculate the total value minus mean. Total is equal to 0. for each row in your grid, for each value in the row, we're going to do total plus equals the value minus this mean, and then just return whether or not this is positive or 0. Alright, then we'll say here the low number of changes is going to be maybe 0. The high is going to be, what is the appropriate high? What's the most operations that you need to do? Your total what is the maximum reasonable operations you have to do? In the worst case, you I'll just try float of many. And then while low is less than high, mid is low plus high divided by 2 if is positive using this mid as your mean. If it's positive, then you try to find a lower number. Try to find a lower number. Right. So it'd be 6. Am I doing this? So eventually this is going to return, the mid value is going to be 3 or 4, and then I have to do the actual calculation with the absolute value. So if it's positive, then make the mid equal the high, else the mid is equal to the low plus 1. And then I do another one where the mean is going to be set to be the mid yeah, I think the mean is the mid, and then do the actual calculation with that mean. Let's just say that I don't need answer 1 or answer 2. I'm just using mean. I'm just going to put an error here. And it doesn't understand my random stuff at the end. Is it taking too long? Go infinite. If it's positive, oh, it's the other way around. The positives are, if you have a low value for your mean, then your calculation will end up being a low value for your mean. total minus the value. Value minus the mean. The value minus the mean. So it's going to be negatives here and positives here. But the negatives are for bigger values, so I think this should be reversed. It should be mean minus value. Yeah. Interesting. Okay, so let's go ahead and do some more. So mid here is going to be is it just too big? So mid here is going to be like, let's say a huge number, like a million. So you plug in a million, your total is going to be a million minus the value. So it's probably going to be too big. So it is positive. So in that case, you should be, if it's positive, then you should be shrinking it. It is high. Okay, let me go ahead and print the mid and positive. I'll do a cap of 5 rounds of this, say 10 rounds of this. Cap is equals 1, if cap minus equals 1, if cap equals 0, then just break. Let's just return. Okay, so your mid is not a number. I guess if you do the mid between low and high, and the mid is not a number, it's false. Okay, I actually need something besides infinity here. So although I guess total, if you do mean minus the value, shouldn't that be returning true? Shouldn't this be returning true? Why is it returning false? Okay, I just need something reasonable. What is the most reasonable thing? If you have a total number, but the total is actually including negatives. So I guess I could do the absolute value. I'll just say largest is 0. After I do this, I'll do largest equal max of largest and the current value of this spot, and the high is going to be high would be that largest value. mid where it's not associated with the value mean equals mid. Oh, at this point should be, it's going to be low or high. It's too big, then it goes mid is one less. So I think it should probably just be mid is the low. Or should mid be the high? Neither works. Excellent. Well, the straightforward cases were solved. Okay, so it's calculating that the mid is 1, and 1 returns false. 1 is probably going to be too... So the first call is when mid is 1, and if mid is 1, then it's a negative number. If it's a negative number, then you increase it. So negative number, you increase the negative number. If I have 1, maybe it should have been value minus mean. Okay. So if your mean is 1, value minus mean should have been positive. Take all these values minus 1. And if it's a positive number, then you need to increase your value that you're looking at. So if it's positive, then the mid should go bigger. Otherwise, the mid should go smaller. I feel like this is just reversing the incorrect logic to make it incorrect again. Why is it always calling 1? So your low and high are is 0 and 3, right? Your mid is 1. It's pod mid, so you go bigger. So your mid is now 2. Mid is, oh my god, I'm so stupid. Low equals mid plus 1, and high equals mid. Jesus, I'm so bad. Okay, now is the hard cases that are still incorrect. So 0 is your low and your high is still largest is 0. Well, I think this should be max is the largest absolute value wise. The absolute value of the value here. So your low is 0, your high is 11. You test 5. Subtracting 5 from each should have been a negative. So therefore you go subtracting 5 from each should have been negative, so therefore you go smaller. Subtracting 2 from each should have been, oh my god. These negatives and positives, man. These negatives and positives are just brutal. I did. Alright, this is just a lot easier if this is just all reduced by the smallest amount in the grid. So I'm going to do one pass just to find the smallest number to subtract everything by. For each row in grid, for each column index, so for each value in that row. We're just going to say value equals min of value and the smallest. And then that's going to be our offset. Okay, this will just make everything so much simpler. Offset will be the smallest value. So I don't have to worry about the absolute value here. And everything should, I don't have to worry about this absolute value either. I'm gonna have to clean up this code here in a bit. Okay, so what stopped working? So this thing stopped working. So 2, if you subtract 2 from everything, it's a positive. And then if you set 3 from everything, it's a negative. Alright, actually this last thing is necessary. Alright. Interesting, what's going on here? Subtract the smallest from everything. If it's not divisible by your x, so let's just return -1. Get your smallest value. Make everything smaller. What is the value here? Print your grid. Print your row/column index. Slow column index. What is detecting it not being false? Shouldn't something be 0 at this point? What is your smallest? Row grid. Your smallest was 0. Smallest is 0 here. You take the minimum of it. guess if everything was, yeah, smallest not zeros, just we'll just make it the smallest, the first number in the grid. Rookie mistake. Okay. 0. I don't think the grid have a negative number at this point. It should have been set to be oh my god, I couldn't actually calculate the smallest correctly. Jesus Christ. Okay. Yeah, so that finally looks correct. So you have 0 to 10. You tried 5. You subtract 5, it's positive. And then if you subtract 8, it's negative. So you try something smaller. So 7 is too big. And 6 is too small. Huh. So which did I use? I probably used 6, right? This should be using the min as the mid, I think. Oh, sorry, that's low. Mid is not always defined. The mean and the high and low at that point is 7. Oh. So it's either going to be 6 or 7. So maybe I just need to test those two values. Yeah, I think maybe I need to just test those two values. So this code is calculating the first. It's going to break when it's not positive. So it's going to be too big. So it's going to be either mean 1 is going to be this value for the low, or mean 2 is going to be 1 less than it. Okay, so we have two answers. Feels like this should still be roughly the same. Oh, okay, so low, if I use 7, this would be 2, 4, okay. So if you use 7, so 5, 5, 10, 10, 5, 3, 10, 8, 0. So if the value is 7, it's going to give you 2, 2. So value minus mean. So it's -2. -2, -2, 3, 3. Value minus mean. -2, -4, 3, negative. Well, 1, -7. And that summation is going to be, you're summing all these values. -2 plus -2 is 4. -2, -4, -6, -10, -17, and then +3, 6, 9, 10, plus -7 overall. So it's not positive, okay. And then for 6, it is going to be 6 minus 5 is 1, 5 minus 6 is -1, 5 minus 6 is -1, 10 minus 6 is 4, 4, -1, -3, 4, 2, and -6. It should be +7 is my guess. -1, 2, 3, 4, 5, 6, 12, 4, 8, 12, 14, 4, 8, 12, 14. So this is +2, and this took 26, and this is -7, which took 27. So weird, so counterintuitive. So I guess the correct answer is probably 5. 5 is 0, 0, 5, 5, 0, -2, 5, 3, -5. And that summed up to be +5, +15, and -2, -5, which is, did I count this wrong? 5, 5, 10, 15, 18, 18. And -7 and 18, which equals the +11, but in terms of actual calculations. Interesting. So the summation of all the numbers, there is a turning point when the summation of the numbers become negative to positive, but that turning point doesn't correspond to the lowest pair of values. The lowest pair of values could still be could be outside of that. How interesting. The lowest pair being the sum of the negative and positive. This is so logically counterintuitive that it's actually breaking me from thinking about the actual technique of solving this thing brute force. Logically, so counterintuitive. So for instance, it's possible that you pick a number such that that number is a number such that the sum of the numbers, one number is positive, one number is negative, the sum of the numbers gets closer to 0 even though the numbers themselves are somehow bigger. Like 18 is bigger than 17 or 10. But 18 is still the correct number to use. Alright. So I think maybe just instead of using binary search where I search for the actual value to use as your difference maker, I just search for this minimum operations. Okay. So that's not true either, because how do I search for this minimum operations? Like, well, that's possible. The number of minimum operations, well, now it's possible. So I mean, the difference between calculating any given possible mean, you're just changing all the values in your calculation by one more, one less. -7 to 11. And by increasing by 1 or decreasing by 1, you're by increasing it by 1 or decreasing it by 1, this is changing it by that same amount, -7 to 11. So therefore, just want to find it so that your number of negatives and number of positives are going to be your number of negatives and number of positives. So how do you tell how many more negatives or how many more positives each thing gets? -17. So the number of negatives that you currently have. 7, 1, 2, 3, 4, 5 negatives. The number of negatives you currently have. Since there's 5 negatives, if you were to decrease your mean by 1, then that number of negatives goes down by that total amount of negatives that you currently have. And similarly, the number of positives would go up by that amount, excluding anything that becomes 0. So how did this work out? So -17 went down to -12 because this is still negative. 1, 2, 3, 4, 5. All those negatives went reduced by 1. And then the positives, shouldn't the positives have gone up to 15? you increase your distance away from the mean by 1. Oh, okay. Your positives are, there's only 4 positives. 1, 2, 3, 4, so down 4, it went up. Now you still have 5 negatives, so it went down. And you still have only 4 positives, so it went up 4. 5 negatives went down, 4 positives went up. And then the next one should have been, your negatives are 1, 2, so you should be going down to your 2, and your positives should go up by 5. 21, but in terms of total things, that's also 25. Interesting. There is some inflection point. There is some inflection point. So your number of negatives and number of positives are changing by some set amount. And then the next one is going to be it's going to be 3 here plus 28 here. That's going to be 31. Because those things. 1, 2, 3, 4, 5, those things. Those numbers negative, these things become negative 1 and negative 4. Wait, what? This thing went down, this thing went down. 4, 1, 1, 6, 6, 1, negative 1. No, sorry, this is 1. Negative 1, 6. 4, negative 2. 4 plus negative 2 is negative 2, negative 3. Plus 1, 2, 3, 18, 22. 1, 2, 3, 9, 15, 16, 22, 26. It adds up to 23. This is actually 29. Did I do that calculation wrong? 0 minus. No, this should be negative 4. Negative 1 plus negative 4 is negative 5. Negative 5 plus 26 is going to be 21. The total number there is 32. Oh. So it's a non-constant number of negatives that you're changing, and you also have a non-constant number of positives then. Negatives are, this should somehow add up to negative 7 to 11. This should somehow add up to 20. What am I doing wrong? This should be positive 25. 1, 2, 8, 14, 15, 21, 25. So that adds up to 20. This is 30 total. Okay. So the sum of your total difference, the sum of your total differences from the mean, including negative differences and positive differences, is going to be changing by your x, or changing by the number of elements in your array. 9 elements, so it changes by 9 each time you bump up the mean. But it's a non-linear, or kind of, there's a downwards and there's an upwards, and there's a minimum to that change in the absolute value of the numbers that are being added. Interesting. So this is still decreasing negatives and increasing positives. There's a decreasing number of negatives and increasing number of positives. And the inflection point is not where it becomes negative positive, but where the values are closest? No, not even that. Because negative 12 and 14 are closer to each other absolute value wise than negative 7 and 18. Oof. Oof, oof. Alright. I thought this was a lot easier than it ended up being. The number of values in the grid. Unity value grid, where all elements of it are equal. So you pick a value between your min and max, and then you it is decreasing and then it's increasing. And the negatives are changing. Wow. What if you kept 2 heaps? Where the heaps are. What if you kept two heaps where the heaps are. What if you sorted the array? Okay, can you do it on a sorted array? Is it easy to do sorted? You're just minimizing the total area of negative and positive differences now. Setting a value such that everything below the value is negative, everything above the value is positive. So if you know how many negatives there are, like the next number here has to be bigger than 30. Like I think it has to be going down and then it's coming up. So if you just count the number of negatives and positives from your mean, and you number of negatives and positives, which value is something between 1 and 10 to the 4th. So it's actually a very small number of values, 10,000 values, 4,000 values, 1,000 values, but there might be a lot of values. Okay, I'm just going to keep track of the count of the number of values. So your values should be capped between your low and high. And if I counted the number of each value, then for each change, I increase the number of positives and decrease the number of negatives. And so I first, yeah. Okay, so not binary search. Let's go ahead and scrap that. Yeah, didn't even work. I don't think, I'm not sure if it could work. So, I'm almost willing to scrap everything, but I think this is usable right now. Okay, so I have a matrix of multiples of x, where the lowest value is 0. I'm going to have a counter, frequency counter. I guess I can just use counter. On I wonder if we can actually pass in here. Okay, so they want you to flatten the list into a 1D array. Okay, so counter is going to be for row, for each row in for each item in the row, and each item in the row in this 2D array for each item in the sublist in array 2D for each item. Wow, this is each item in the sublist in the 2D array for each item in, oh, these items are referring to different things. Oh my god. For each row in the sublist for each row I don't think these items are referring to the same item. Item, the sublist being the row. For each item in the row. Okay. Value in row in the grid. Value in row value for the row in grid for value in row. Okay, so the counter is going to have the sorting values for each row in the grid for each value in that row. Frequency counter. Okay, and let's go ahead and so we're just going to go through all the possible frequencies. So for each mean in the frequency, the low is still going to be, lowest will still be 0, the largest will be, okay. For each mean in okay, the number of positives. The number of positives, if you subtract it as 0, the number of positives is going to be the count minus the frequency counter. Okay, I'll just say frequency. The frequency of 0. That's the number of positives. The number of negatives is going to be 0. And then for each mean in the range of your possible values, which is from 1 to 1,000, so from 0 to largest, so range is largest. I think it has to be 1 to largest. Starting with 1, I guess it could be largest as well. If it is, if there is something that is of that frequency, then this changes the positive and negative. So if there are some 1s, the 1s would become 0s. So the positive would minus equal the frequency of this value, of this mean. And the number of negatives would be increasing by however many small values were. If the mean minus 1 is in frequency, then the negatives increase by that amount. And then the answer is equal to the answer, the minimum of the absolute value of the positive minus the negatives. then terminate triple string literal. Minimum of that in the previous answer. Minimum. Okay. So tough these two kind of trivial cases. Alright, let's go ahead and just do some sanity checking here. Print out my grid after making the changes, print out my frequency of the stuff in the grid. Okay, so there's 5 3s, 10, 3, there's 3 5s, 3 10s, 1 3, 1 8, and 1 0. Okay. Let's go ahead and print the initial. Positive and negative. Oh, the answer is, gosh, the answer should not be 0. It's going to be minimized. So the worst case answer will be, I don't know, largest times count. Okay. So initially, there's 8 positives. So there's 9 numbers, one which is 0, so there's 8 positives, sure. And there's 0 negatives, okay. So after each loop, go ahead and print out the mean that's currently used. It really shouldn't be called mean, it should just be called the offset. Map number positive and negative. Yep. Okay. So when it's 1, it doesn't change anything. When it's 2, it doesn't change anything. When it's 3, there's 1 3, so the number of positives decrease by 1. The number of negatives is still the same. When it's 4, the positives decrease by 1, the number of negatives increase by 1. Oh my god. Oh my god. I need to have some initial value that's not these values. The initial value should be, what should it be? The initial value should be you're changing the number of positive and you're changing the number of negatives. Time you decrease the mean. So the number of positive things I wish I didn't delete the sample stuff. Number of positive things. So you start with 0, and you start with the sum of all positive values. Alright, so that means that you have some initial sum. For every row and grid, every value in the row, let's go ahead and create the total sum of the positive stuff. Total positive is going to be plus equals the number. Yeah, it's just the freaking total. Okay, if I just have the freaking total, then I already calculated that before, no? Okay, so that total is the total positives. And then the total negatives is going to be equal to 0. And each time you bump up by 1 your offset value, your total positives should decrease by the number of positives. So you bump up by 1, total positives should decrease by the number of positives. And your total negatives should increase by the number of negatives. And then you change how many positives and negatives that you're counting. And then you take the minimum of your total positive and the minimum of your total positives minus total negatives, because the negative value is going to be negative. Yeah. Okay, you're starting with 56. So the sum of all these numbers away from the 0 is 56. So 5, 10, 20, 30, 35, 38, 48, 56. Alright, so you increase it by 1. So that means all your positive numbers, of which there's 8 of them, is going to decrease by 1, so it's 46. And all the negative numbers, of which there's 0, is going to increase by 1, so still 0. Minimum of the absolute value. Minimum of the absolute value. Okay, let's keep on going here. So 41, 41. The negatives are actually looking at positives, so it's actually a total positive plus 2 negatives. So you bump it up by 1. Your number of positives is still 8. Your total number of positives is 48 is 40. And your total negatives is -1. That's 41. That's 34. 28. 23. 21. Yeah, this should be this should be would this be -1? Should be changing by 9. Should be changing by 9. Should be counting 0 as a negative. Total negatives should, total positives should decrease. And your total negatives should increase, but your total negatives should be, you should be counting 0 as negative. That doesn't feel right. Should be counting 0 as negative, because as you increase your negatives, yeah, or I guess negative is non-positives. Alright. So initially you have 8 positive and 1 non-positive. And that was 56. Okay, and your total positive is 56 and your total negatives are 0. Fine. And then the next one, your total positives is going to be 48 and your total negative is going to be -1. And that's 47, 56, 47 is 9. And then 40, and this is going to be 37. 47 to 37 is 10. It's not right. So if the mean is in the frequency, so I don't think this should be mean -1. I think this should just be mean when you increase your, this is positive and non-positives, so farther and farther away from the correct answer. Okay, 56, 47, 38, 29, 19, 29, 21, 23. Okay, so those numbers are kind of matching what I was thinking. But why is it getting, why are these numbers so small? Oh, you're increasing by the, oh geez, frequency -1. Frequency. Oh. Okay, so this thing can go away. It's not really positive and non-positive. Isn't positive and non-positive always going to be the same calculation? Your total positive, your total. Your non-positive is something, and your count non-positive starts with 1. Then you just change by the same amount. Okay, this is gonna make me confused. So this is just the offset, not really the mean. So it is going to be between the high and low. For each offset in frequency. There has to be some logic that I'm missing here that simplifies this. Oh, Jesus. So you're decreasing the total positives by some amount, and that amount is changed by the number of minus equals positive, where positive is the frequency of the offset. If the offset is a frequency, the number of positives changes. I think I can possibly just okay, I can use, instead of a counter, I can just use an array here. What's the size of this array? It's going to be frequency is just going to be array of zeros times the largest plus 1. And I can just, instead of asking if it's in there, I just say it's all in there. Okay, just testing that change worked. That change did not work. Frequency is the largest plus 1. Didn't go out of bounds at least. Oh, I didn't actually create the frequency. Actually, I'll say this counter C equals counter for value for each row in the grid for each value in the row. And then for each value in that frequent F in that SC, we'll just create the frequency for it using the flat array. frequency of f is equal to fc at this spot. Okay. And then last, we get rid of prints. See how this goes in the bigger case. Oh my god, I still don't answer. Holy bejeebus. Sweet mother lord. Okay. And print out the stuff here. Use this test case. Alright, 11570. Okay, so the frequency print the frequency counter, the raw stuff. Okay, there's 4 9s, 2 5s, 2 7s, 0 2s, or 2 0s, 1 11, 1 1, 1 3, 1 10, 1 6, and 1 8. Initially, the low is going to be, the number of positives is 14, and the number of negatives or non-positives is 1. The sum is 99. This is a 16 element 2D array, so each chain should change by 16. So 99, so 85 and 1 is 84. Oh, the number of negatives is not 1. It's actually starting at 2. So it's actually the frequency of 0. What am I doing? Okay. That was a pretty straightforward fix. Still wrong. Okay. Alright, so there's a bunch of zeros and ones. That's all there is. So initially, so there's 1266 zeros and 1234 ones. So initially, I guess the initial answer should just try to use the initial condition. So answers the absolute value of the starting total positives, or I guess total negatives is going to be 0 at that point, so total. Alright. Oh baby. 17%. Yeah, this is positive. So get the smallest value. And then I guess you can just do this check beforehand. Pick up your smallest value. You change the array to make it make it the smallest. And then you also find your largest. I guess that wasn't strictly necessary. Okay, just to simplify here, we'll say largest. I guess since we did flatten the array at some point, flat array is equal to all that jazz. And we'll say smallest is equal to the min of flat array, and largest is equal to the max. So that get rid of that, and we'll say FC is the counter for the flat array. Make sure that still works. Guess I delete too much rows. Columns is equal to length of grid at 0. Can get rid of this largest. This calculation. I do something wrong. Total. Go ahead and print out stuff again. So that stuff at the end works still. It should still be correct. Did I change? That would make it incorrect. Flat array is an array with all the values. This looks like the same as before. Frequency of 0. The answer is equal to total. My new answers are all just too small. Counter is 0, 1, 2, 3, 4, 5. Oh, my values. Interesting. Okay, I see. I think I see. I think I see some way of decreasing the speed. Okay, so what I do, got rid of that, set my smallest to be the min of the flat array. The smallest should just be 0. No? No. Should definitely be subtracted this. So I think that's still fine. That's still fine. The frequency counter is calculated up here. Oh, the frequency counter was calculated after I flattened it. After I flattened the second time through. Also, the largest was calculated after I flattened it. So how to fix? So I flatten it, I find the smallest and largest. I guess if I just work with that flat array at that point. There's no real reason why I'm working with a 2D array versus just working with a flat array. There's no difference. Okay, just get rid of all this stuff. For each index in the range, the count of the number of values. Flat array at this index is equal to minus equals the smallest. If flat array at this index mod x is not 0, turn it 1. Else flat array at this index divide equals x, total plus equals this value. Total is initially 0. And then in here is when I do the frequency counter. I think here is also when I should do the largest calculation. Okay. And here, that calculation is fine. Still probably too slow. Oh, okay, it's faster. I think the total positives and total negatives, they should be the same calculation, no? And total positives. Total positives subtract by decreased by. Okay, so why can't you just absolute value of your total positives plus your total negatives. Total Total positives decreasing by total positives decreasing by some amount that's matches your total negatives. So couldn't we have one variable that tracks both? Total positives decreases by the frequency at the offset. Total negative increases by the frequency offset. But somehow, when you add them up, they still end up being different. How is that possible? Fundamentally, the intuition is off for me. Total positives. What is going on with these things? $99, $85, your absolute value number of positives and number of negatives. Frequency of the offset, which oftentimes is 0. Frequency of the offset, which is oftentimes 0. So, because your positives and your negatives change. If you have a 0, if the frequency of the offset is 0, then you skip it. So maybe you can do if frequency of offset equals 0, then continue. And you should only really do this as long as the answer is decreasing. If the answer is increasing, then then you know that you've reached your minimum. So if the total positive plus the absolute value is total negative is less than the current answer, then answer equals absolute value total positive plus total negative, else break. Okay. Should be faster. Terribly. I could possibly do is go through the sorted list of frequency rather than every value. There's only 1,000 values, it can't be that much faster. Total positive equals total. Alright, so I'll just say this total positive right here. And this is the total positive right here. Total negatives 0. I feel like you shouldn't need to keep track of your negatives. Your negatives is just the number of non-positives. So this is all redundant somehow. Your total positive subtracted by that amount, and the total negative. Total positives subtracted by the number of positives. And your total negatives is added to the positives. If these are the total positive, and this is your total negatives. $99, $85, and -2. Your total positive and total negatives add up to what did I just do here? 85, 16, and 29, 45. Do I even need to take the absolute value here? Why am I taking the absolute value? Answer equals total positive initially. Okay. I don't know if I need the absolute value here. Seems like I don't. But probably I do not. Change it by the frequency. Count minus the frequency. Okay. That's things I need to print out. Let's print out the total positive, total negative, and positive and negative. And the offset here. Okay, so total positives, that's a decent one to look at. Total positives was initially 99. There's 16 elements, so it needs to go down by 16 each time. So 99 0, 85 -2, 59 -8, 9 and negative 38. So how much it went down by was dependent on the frequency of certain numbers. So the smallest frequency might be 1, so go down by 1. They go down by 1 on one side, and we go down by the total count minus that frequency on one, minus that frequency on one side, and increasing by that frequency on the other side. So here the frequency of the smallest number was, which was 56, was 2, so increase it by 2. Goes down. So you're changing by some frequency. Okay. So you're going down on one side, going up on the other side. But going down on one side is positive. And you're seeing where it changes. Total positive changes by the number of positives. The number of positives is the frequency of the offset. Total negative changes by the number of negatives, and the number of negatives is also the frequency offset. So the total positive. So how does the total positive and total negatives not add up to the same thing each time? You add up 85 and 2, that's 87. And add up 59 and 8, that's add up 25 and 22. What are positives to the negatives? Alright. Is there a way to optimize this? Oh gosh. Feel like there should be like your total positives subtracted by this frequency and your total negatives increased by the frequency, so the total difference should be the same. It's all count. I guess the number of times you change it. So the number of times you change it. So you increase it by 2, but then you increase it by 6 the next time. But between the time where you increase it by 2 and the time where you increase it by 6, you also increase it by 2 again. Yeah, you increase it by 2 again. The current number of positives. Okay, so I guess you really can't. Yeah, I see. Your total negative at each point in time is adding up this new negative value, and this negative value is different than the positive value. Okay, then you definitely cannot. You can still the frequency of the offset. You could probably just condense these two though. Because the positive changes by the offset value, negative changes by the offset value. Yeah, you should be able to say that this is changed by the positives and the count minus the positives here. I think that's still fine. Alright, at least you got rid of that. What's that's worth? If it's less than, decrease it, else stop. Get rid of the rows and columns bit. Count is just the size of this thing. After you find it, and if the count is 0, return. And we'll say the total positives is initially 0. Alright, even slower than before. Excellent. Okay, that's it. I mean, summary of algorithm. I honestly don't know. I honestly don't know why a simpler method doesn't statistically work. Time complexity. This is going to be O of n, where n is the number of elements in the 2D array, but also it's actually O of n times v, and v is the range of values. Like I specifically hard-coded the array of frequency array. Needed for frequency array, and we did go over not every index in the, so we went over the indices of the original array, but then we went over the actual values of the frequencies. The frequencies of the values, not was in the other array. Space complexity, this is going to be O of n plus m. So create an array, 1D array for the 2D array, and then also create a frequency counter that's size the